Off Canada's Pacific coast, researchers are hoping to make a long-held dream come true. Behavioral biologists and IT experts have teamed up to create programs aimed at deciphering acoustic signals from animals. Could artificial intelligence help to identify patterns in the sounds made by marine mammals? Will we soon start to understand what it is that whales are talking about? The coastal waters between Alaska in the US and Canada's Vancouver Island are where a group of killer whales, or orcas, spend their summers. A team of scientists from the DeepAL research expedition are preparing to embark. DeepAL stands for Deep Learning Applied to Animal Linguistics. Computer scientist Emma Noeth from Germany's University of Erlangen has spent years working on automatic recognition for human speech patterns. Can the same methods be adapted to animal languages? Underwater microphones embedded in tubes serve as the expedition's ears. For 3 summers, teams of computer scientists and biologists have set out to record orca calls and document whale behavior. Rachel Cheng from the Leibniz Institute for Zoo and Wildlife Research in Berlin is looking for patterns between behavior and animal vocalizations that could help to decipher whale language.
I assume they would exchange information. They may have a very, very different system, which may not fit into our prototype of language.
Around 300 orcas are identified as northern residents, as they spend each summer along the coast of Alaska and northern British Columbia. They live in small family groups and are very communicative. Do different families use different dialects? And is it possible to discern the meaning of individual calls? Here, the researchers lower the highly sensitive microphones into the water. The 8 hydrophones can record sounds up to a frequency of 100 kilohertz. That's far higher pitched than what is audible to the human ear. Thanks to the network of hydrophones and acoustic triangulation, the researchers will later be able to calculate the positions of the whales. To avoid disturbing the whales with engine noise, the research trimaran is equipped with an electric motor. While visibility is limited underwater, sound waves are transmitted over considerable distances. That's why a communication system with loud calls is clearly beneficial.
They're very tight together and frequent direction change, circling, and body twisting.
Yeah.
And plus a lot of echolocation. They're socializing like the USC. They bump into each other and rub and frequent twisting and then jump onto each other.
It sounds like they talk about the plan. What are we going to do next or something?
Orcas only spend about 5% of their time at the surface, which makes systematic observation quite difficult. The research team uses drones to document the behavior of the animals. Diving expeditions with whales are prohibited in Canada. The scientists are looking for the smallest meaningful units of communication. Which whale is calling? And which one answers? Are some sounds repeated more than others? Biologist Elisane Durand examines the recordings. Each call comprises a series of brief pulses, which sound like melodic curves to human ears. Each shift in sound could be meaningful. While recording the whale calls, the researchers also document the behavior of the animals.
So there's 4 individuals in this group here that are circling. There were 4 back there with the male. There's one that I can see out of the corner of my eye coming towards us, and the mom and calf. So that's 8, 10, 11 individuals minimum.
The more data available, the easier it is to train deep learning programs to decipher whale language. It's therefore a major advantage for the researchers that over 20,000 hours of orca calls have already been collected, more than for any other animal species. Whale researcher Jared Towers has been tasked by the Canadian government with observing different orca populations. Back in the 1970s, scientists here began documenting individual animals, as well as their group structures.
A108 straight underneath the boat here. There she is. She's going off up ahead.
Towers has no problem telling the orcas apart.
So this scratch here on A108 has persisted for at least a couple years now. So the way that we identify the individuals, no matter what population they belong to, is by appearance. And you know, you get used to looking for certain features on an individual killer whale.
The dorsal fins and the patches around the fins have different shapes, enabling scientists to catalog each of the northern residents. Every family forms a lifelong bond.
What we're looking at with all of these families is an adult female leading the group, and the fathers of their offspring don't play much of a role in that family group.
Jared Towers works for a federal institution that safeguards Canada's waters. His former boss, John Ford, was the first to distinguish between the disparate calls of the whales. Ford's research revolutionized our understanding of the communication system used by the resident orcas.
What we're listening to are calls of A-clan whales. That's the exciting part of underwater listening, is you're getting a window into their life that you would never see.
John Ford discovered that the whales use about 50 different calls. Different families prefer different types of calls. These were nicknamed dialects and used to help identify individual families.
When they're making the various stereotype signals, it's simply to keep in touch with everybody in the group. They exchange them. They're constantly monitoring each other's location because they can tell where they are because of their very directional hearing. And they can monitor the sort of behavioral state, the excitement level, the arousal state of all the other animals in the kin group.
Northern resident orcas visit pebble beaches daily.
You can hear them rubbing right now. They're making socializing sounds, and you can hear the pebbles getting pushed around, and they just rub all sides of their body, just in the shallow part of the beach.
Only a few orca groups worldwide engage in this sort of body rub. This behavior is not genetic. Rather, it's a tradition passed on within families of the northern residents, just like their language. Back on the German-Canadian research boat, it's a challenge to locate each family among the 300 individuals that make up the northern resident population. The orcas are constantly on the move in an expanse of water the size of Belgium. The expedition covers an area from Vancouver Island to the southern tip of Alaska. Seagulls indicate where schools of salmon might be. And this is where orcas often hunt too. Calls from the A-clan can be heard on the underwater microphones. The team tries to determine the position of the whales.
This comes from the left, this comes from the right.
They compare the calls with a catalog compiled by John Ford, but they encounter discrepancies. The calls of Class N9 are used by different whale families. Calls from the same class should be almost identical, but these differ in length, melody, and harmonics. Human analysis so far has amounted to only a rough classification.
Looking at the spectrograms, I'm very sure that we can, achieve something that rivals the human performance.
Two whale families approach. What calls are they exchanging?
Was that call? Okay, just to record this. After I hear the call, the back group surface, and then I spotted the front group turn around.
The researchers are interested in which group is calling, which one answers, and which sounds they're using.
So look here, the I-4 is approaching the boat, and you can hear a lot of calls. And here we can see the calls they make.
Oh yes, it's N23.
So there's a lot of variations also. And interestingly, here's the A23 families.
The chords look really different.
Yeah, it's how people differentiate different materials.
If we have a lot of chords from them, we can try to train a classifier.
The programmers use algorithms or classifiers to automatically analyze millions of whale calls in order to compare recurring sound patterns with recurring behavioral patterns. This same method is used to decipher the meaning of individual words in foreign languages. For Elman Nutt and his team, it's no easy feat to automatically filter out the weak orca calls from the constantly fluctuating noise of the ocean. By matching thousands of orca calls on the input side with a target value on the output side, they train neural networks. These layers of neural networks then learn, bit by bit, which sounds are typical for orcas. The purple peaks indicate a high probability of having found a whale call. It's the first time a machine has been trained to automatically detect orca sounds. Still, clustering calls into similar sound groups remains a big challenge. When comparing tens of thousands of recordings, all whale calls are sorted by what they have in common. But the cluster is still too crude to form reliable classes. Further programming is required. The team suspects that the northern resident orcas have a complex language system and may even process more intricate sound patterns than humans. But how much is even known about the acoustic capacity of their brains? This is Telegraph Cove on Vancouver Island, where Elman Nutt and Rachel Cheng have an appointment. Only a handful of researchers worldwide have expertise on whale and dolphin brains. Neuroscientist Lori Marino is one of them.
So is this an orca brain?
This is an orca skull, a cranium, right, of an orca. And in the front, you would find the melon, where they do where they direct the echolocation. And this part right here, this large part is where the brain would sit.
Wow.
Okay.
Yeah.
Human and whale brains generally share the same mammalian architecture. Both cerebral cortices are wrinkled and complex. But the orca brain is 5 times bigger, among the largest of any animal. And unlike the human brain, the orca also has a paralimbic lobe.
The part of the orca brain that really fascinates me is this part right here. We have this special extra lobe called the paralimbic lobe. So it connects feelings, emotions, and thought. And it is so complex in the orca brain, it has become its own globe.
Okay, so that could mean that a lot more of the communication has to do with their feelings, with their emotions.
That communicating feelings, communicating emotions are very important to an orca.
Okay.
Whales have a far larger acoustic area than humans. Lori Marino's team also discovered a second acoustic cortex.
Now we know that they also have a sound processing area in the same area that we process language.
Based on what you said about how they process sound, can we say that we need a much finer window when we analyze?
So it's not just fine resolution that we need a way to actually do the analysis at a much more complex level than our brains can do it.
New brain scan methods have revealed that orcas have a far more complex acoustic system than previously believed. Could the same be true for other marine mammals that use sound for their communication and orientation? In contrast to other orca groups, the northern residents at some point stopped hunting seals and other marine mammals. Today, they feed almost exclusively on the largest salmon in Canadian waters, the Chinook. Stocks of the fish, however, have been declining rapidly since the late 1990s. The northern residents have to travel increasingly long distances to find the salmon that still remains. And despite stringent fishing quotas for the species, their numbers continue to decrease. Jared Towers from Fisheries and Oceans Canada monitors if people are complying with the fishing regulations.
It seemed to be that when Chinook salmon aren't quite so abundant, the killer whales aren't getting enough to eat, and that causes the population to go down a little bit.
The northern resident orcas are classified as a threatened species.
When Chinook salmon abundance is low, they don't simply go out and try catching other fish. They haven't learned or they haven't found an ulterior prey resource. It's not like they're going to go out and start killing harbor seals just when there's not enough salmon around.
The substantial human appetite for salmon has decimated stocks to critically low levels. The ruins of the salmon fishing industry serve as a reminder of the once abundant fish stocks. Wild Canadian salmon were in great demand around the world. The survival of the northern resident orcas is tightly linked to the fate of the Chinook salmon. Lance Barrett Leonard is a geneticist and behavioral ecologist at the Vancouver Aquarium. He visits the resident orcas every summer to document their long-term health and measure how their body size and shape compares to previous years. To ensure the images are comparable from year to year, the drone hovers exactly 30 meters above the whales.
We're almost over them.